This is Activity 1, Different Equations for Lesson 4, More Balanced Moves. And in this activity, you're given 4 equations, A, B, C, and D, and you're supposed to decide whether or not these equations have the same solution as the target equation up here, which is labeled equation 1. Now, there are several ways to do this. One way to do this is to solve this equation for what is the value of x. And if you do that, you're going to find out that x equals 1. It's not that hard to see. This is adding a negative 3, so if you add a positive 3, this becomes 5. This is adding a negative 4x, so if you add a positive 4x, this becomes 5x. So you get 5x equals 5, x equals 1. So that's not too bad. And then what you can do is take that 1 and replace it for each of the x's in each of these equations. And you're going to find out that all 4 of them, in fact, do have the same solution. So they're all different forms of this equation up here. So just as a quick example, if I replace x with 1 here, this is 2 minus 6, that's negative 4. Or 2 plus a negative 6 is negative 4. And this is 4 plus a negative 8, which is also negative 4. So this is negative 4 equals negative 4. So x equals 1 is the solution. Another way to do this is to solve each equation for the value of x. And we just talked about that this is x equals 1. And if you do that for each of these 4 equations, you're also going to get an answer of x equals 1 for all 4 of them. So again, it shows you, or it proves that each of these 4 equations are different forms of this equation up here. They all have the same solution. Now, the way that I'm going to show you is really what gets at the heart of these lessons, which is how do you change equations from one form to another by manipulating the terms, by adding, subtracting, multiplying, and dividing. And I've been through many times the reason that I like to focus on adding. So I add the additive inverse, or I add let's just leave it at that. I add the additive inverse, or I just add, or I multiply, and sometimes I'm multiplying by the multiplicative inverse. It really kind of depends on what you're doing. But the point is to focus on addition and multiplication. And so for this first one, I'm going to change the form of each of these equations, and this is where I'm going to start with the addition part. I'm going to change, this is subtracting a positive 3 here. So this is a positive 3, and this is subtracting a positive 4x. Now I'm going to change that to adding a negative 3. That's the same thing. So think about it. If you subtract positive 3's, you're going to move to the left 3 units on a number line. If you add negative 3, you're going to move to the left 3 units on the number line. It is doing the same thing. So I'm going to change this to adding a negative 3 and this to adding a negative 4x. And the main reason I like to do that, really 2 reasons, but one reason is to make sure I don't confuse the operation with the sign of the term. So I want to make sure that I don't get confused on that. So I always keep it what it's supposed to be. The other reason to do it is that you can then easily use the commutative property to move terms around if they're not arranged in a way that you want to. All right. So I did the same thing here. I changed this to subtracting a positive x to adding subtracting a positive 6 to adding a negative 6, and subtracting a positive 8x to adding a negative 8x. And so the task now is, how do I change this equation here back to the target equation? So I'm going to call this the target equation. So how do I change this form back to here? And the most straightforward way to do this is to realize, to look at each of these terms. I'm going to look at each of these terms here, and to realize that each of them is 2 times the corresponding term up here. So 2 times x is 2x, 2 times negative 3 is negative 6, 2 times 2 is 4, and 2 times negative 4x is negative 8x. That means to change this equation back to this equation, I can multiply by the multiplicative inverse, which is 1/2. So if I multiply each of these terms by 1/2, and you remember that you have to multiply each term by 1/2. You can't just do 1 on one side and 1 on the other side. It has to be all 4 terms. So if you multiply all 4 terms by 1/2, you get back to this target equation up here. X plus a negative 3 equals 2 plus a negative 4x. Now the lesson is going to be look for multiplication first as you work with these equations, because the first time I did this, I did not do that. I thought, well, I think I can use addition. I should be able to use addition to change this equation back to this equation up here. And I really turned this into a mess. And so I'm going to go through it a little bit because I learned a lot by doing it. But if you don't want to look at it, don't want to think about it, I would use the table of contents below this video and click to equation B in the table of contents, because I'm going to take a little bit of time to go through different ways to work with equation A. So I looked at this and I thought, all right, I'm going to change this to negative 3 right here. So I'm going to add positive 3 and change this to negative 3. And I'm going to change this to just a single 1x. I'm going to try to get this to x plus negative 3. So on this side, I'm going to add a positive 3. And so I have to add a positive 3 to this side. And I'm also going to, so I'm doing actually 2 steps at one time. So I'm going to also add a negative 1x to this side, which is going to change this to x, and a negative 1x to this side. So if I do that, I get x plus negative 3. And then what I was expecting to happen is this would become the right side. Well, it doesn't. It's something else. It's 7 plus negative 9x. And I thought, well, gee, I don't know what's going on there. I don't know why that is. And so I played around with this for a long time, and I finally realized, well, if this equation here is equal to x plus negative 3, and this expression, here is equal to this expression, x plus negative 3. That means that these two expressions are equal to each other. So I can write them as being equal to each other. So 7 plus a negative 9x is equal to 2 plus a negative 4x. All right, so now can I go through the same idea and change one of these to x plus negative 3, and will the other one become 2 plus negative 4x? So that's what I'm trying to do here. So I'm adding a negative 10 to make this negative 3. So add a negative 10 to make this becomes then a negative 8. So this is negative 3. Okay, now if I'm going to change this to a single x, I'm going to add 10x to that. So 10x plus a negative 9x is equal to x. And we're going to see if this right side then becomes this 2 plus negative 4x up here. So I did that. So now I have negative 3 plus x. This is the same as this up here. It's just switched. Negative 3 plus x. But the right side is not 2 plus negative 4x. It is actually negative 8 plus 6x. And I think, man, I don't know what's going on here. So I thought, okay, well, let's continue. What if instead of changing this side to negative 3 plus x, what if I change this side to negative 3 plus x? So I'm going to add a negative 5x here. So that makes this x. And I'm going to add a negative 5x to this x. That makes that a negative 4x. And I told you I made a mess of this, and this is what it is. So now I'm at a negative 3 plus a negative 4x equals negative 8 plus x. So now if I change this term right here to negative 3 by adding positive 5, and actually all of this reinforces how you work with equations by doing balanced moves. It's just this is a very roundabout way to show this. All right, so I'm going to add a positive 5 here and add a positive 5 here. So negative 3 plus positive 5 is 2. And negative 8 plus positive 5 is negative 3. So here's the x plus negative 3. And this is the use of the commutative property. That's why I want this to be addition. So this is just switched up from up here. So it's really the same expression. And this is 2 plus negative 4x. And finally, it's 2 plus negative 4x. Well, I don't really understand what's going on here. But I finally did get to this equation from the starting equation, this equation right here, which I finally did get to this target equation is what I should say. All right, so again, if you don't want to listen to this or watch it, I would click on the table of contents to equation B to go to equation B, because I'm going to do this a couple more times. And trying to figure out what's going on here, I wrote a simple equation. I just said, okay, 5x equals 5. So I can double each of the terms and rewrite this equation as 10x equals 10. Now, can I use addition to go from this equation back to this equation? So can I get back here? I could just multiply by 1/2, right? That would, that's the inverse operation of the multiplicative inverse of 2 is 1/2. So I could multiply by 1/2 to return this equation to this equation. But I want to use addition. I'm kind of hard-headed about, I want to show this should work. All right. So I'm going to change this equation to 5x by adding a negative 5x. So this becomes 5x. So this same 5x here. So what happens to the right side? It should become 5. Well, it doesn't. It becomes 10 plus a negative 5x. So I had the same realization as before. If 5x equals 10 plus negative 5x and 5x equals 5, then those two expressions are equal to each other. They both equal 5x. That means they have to equal each other. So 10 plus a negative 5x equals 5. And now finally, if I add a positive 5x here, that 5x shows up on the other side. If I add a negative 5 here, 10 plus a negative 5 equals 5. So you finally get 5x equals 5, which is the original equation. It's just switched over the equal sign. All right, well, that's a move in the right direction towards understanding this. But now it becomes easier for me to ask the question, well, what happens if I, instead of multiplying each term by 2, I multiply each term by 3, I multiply each term by 4? Can I detect some kind of pattern? Can I see what's going on? So if I multiply each term by 3, this becomes 15x equals 15. Now can I use this and use addition to get back to here? So same idea. I'm going to change this 15x to 5x by adding a negative 10x. Now notice that this is two groups of 5x, actually two groups of a negative 5x. So I'm going to end up with 5x equals 15 plus a negative 10x. Again, kind of a mess, but I have these two groups of a negative 5x here. And the same idea as before, 5x equals 15 plus negative 10x, 5x equals 5. So that means that this 15 plus a negative 10x equals 5. So once I do that, I can add a positive 10x, get rid of this. That positive 10x shows up over here. Add a negative 5 to get rid of this. 15 plus a negative 5 is 10 equals a negative 10x. Well, this is the previous equation. This is back here. This is this equation right here. So this equation. So now if I just repeat the same thing, I will get back to here. That's doing this right here. So we're working with this, going through the same steps, I'll get back to the target equation. So it looks like if I triple 3 times this 5x and this 5, then I have to go through these steps twice because you end up with two groups of these 5x's. In this case, they show up as a negative 5x. I don't know if that makes sense, but let's try it again. So what if I use 4 times 5x and 4 times 5? So now I have 20x equals 20. So to get it back to 5x, same steps. I'm going to add a negative 15x. So add a negative 15x over here. Come to the same realization that this 20 plus a negative 15x is equal to the same 5. So notice you have all these different expressions always equal to 5. So now if I add a negative 15x, a positive 15x, this 15x shows up on this side. Add a negative 5, this becomes 15 equals 15x. Well, that's the last equation. And then this is the equation before that. So it looks like if I multiply each side by 4, I end up with 3 groups of these negative 5x's. So I have to go through this process 3 times to return to this original equation. I don't know if that makes sense. It has something to do with multiples. Frankly, I don't quite understand what's going on. I would have to talk to somebody that knows a lot more math than I know to have this explained to me. It's part of the reason I'm including this in the video, just as a record of what I was thinking, so later on I can ask somebody. So I decided, okay, let's take a very simple equation. Let's take x equals 6, double each side, so 2x equals 12, and then triple each side, so 3x equals 18. We go through the same process, so 2x plus a negative 6 equals 6. So I'm going to remove 6 units from this 12 to get this to this side of the equation, to get this to be equal to 6. So now I'm left with 2x equals a negative 6, and we know that that equals x, because both of these now are equal to 6. 2x plus negative 6 equals 6, and x equals 6. So now I have 2x plus negative 6 equals x, and so if I add a negative x here, this becomes x, and if I add a positive 6 here, this becomes 6. So I get back to this target equation. So that's doubling. So if you double each side of the equation, each expression, then it looks like you have to go through this process using addition just one time. If I triple it, I'm going to end up with 2 groups of this negative 6 here. So that means I'm going to have to go through this process twice. So this is 3x plus negative 12 equals 6, and x equals 6. So 3x plus negative 12 equals x. You end up with 2x equals 12, which is this equation here. And then you go through the process one more time. All right, so let's go back to here. Since this was doubled, that means I should have only had to have gone through this process one time to return to this equation using addition. And I didn't. I had to go through a bunch of stuff down here. Turns out that if I had chosen to make the right side x plus negative 3, so I would add 5x to this side, I'd add 5x to this side, this would become a negative 4x, which is right here. And I would have added, this is a negative 3, I would have added negative 5 to this side, so that would make this, I would have added negative 5 to this side. That would have made this negative 3, and a negative 5 to this side would have made this a positive 2. So this would have become 2 plus a negative 4x, and this would have become x plus negative 3. So in one step, I could have returned this equation right here back to this equation up here. So I just chose the wrong side. I don't know how to determine which side to begin to work with. All right, so the bottom line in all of this is when you're looking at an equation and you want to change the form of that equation to another equation, begin by looking to see if they're related by a common factor. And the common factor in this case was 2. 2 times x, 2 times negative 3, 2 times 2, and 2 times negative 4. So look for that first before you begin adding to both sides of the equation to change those equations. Now the next 3 problems, well, this one's a little bit different, but the B and D, you do simply start by adding. So for B, you're going to change the form of this equation. So this is x plus a negative 5 equals negative 4x back to this target equation. When you look at it, multiplication doesn't work because this is x and this is x. The negative 3, negative 5, this is negative 4x, negative 4x. So you can't get from here to here using multiplication. But if you look, the only thing that's missing up here, or one thing that's missing from the negative 4x is this 2. So I would begin by adding 2 to both sides. So you add a positive 2 to this side and a positive 2 to this side. This side now is the same expression as this side. It's just using the commutative property to move these around. And a negative 5 plus a positive 2 is negative 3. So that's this negative 3 right here. So this does work. X plus negative 3, this has become negative 3, equals a positive 2 plus negative 4. And I use the commutative property to just move these, switch the order of these two. So that works. Look for multiplication first. If that doesn't work, then go to addition. So this next one, C, when you see this, think of the distributive property. This is two groups of whatever's inside these groups. So the first thing to do is to get these two terms out of the groups. Well, I have two groups of one thing in each group. That means I have two things. 2 times 1 is 2. So if I look inside two different groups and I see one thing, or the same thing in each of those two groups, that means I have two of those. And if I have a negative 2x in each of those two groups, that means I have a total of a negative 4x. 2 times negative 2 is negative 4x. So now I've taken these out of the groups, and you see that it is the right side of this equation up here. So 2 plus negative 4x, 2 plus negative 4x, x plus negative 3, x plus negative 3. So that does check. And I just, I move these over the equal sign, and you can show mathematically how to do that. But eventually you just realize whatever's on one side of the equal sign, you can move over to the other side. And you can move the whole expression over to the opposite side. All right, the last one, which is D here. All right, so I changed this to adding a negative 5x, and so now can I change the form of this equation to this equation? And again, multiplication doesn't work. I have 2 plus a negative 5x, I have 2 plus a negative 4x. I can't multiply every single term to change all of these terms into this in some way. So I'm going to then look for addition. So this is 2 plus a negative 4x. So if I add a positive x here, this will become a negative 4x. I think I said 2 plus a negative 4x. I have 2 plus a negative 5x. If I add a positive x here, this will become a negative 4x. So let's do that first. So I'm going to add a positive 1x to each side. This becomes 2 plus negative 4x, which is the same as up here. And by adding that 1x to this side, this becomes x plus negative 3, which is this side. So that works. Just that simple change of adding a positive 1x changes the form of this equation to this equation. And it shows that these are two different forms of the same equation. So that works. So here's everything all written on one page. And the key to equation A is to make sure you check multiplication first, and you'll find that it's 1/2 times each term.